Good morning, good afternoon, good evening, and welcome to this instance of the Antrea community meeting. Today is August 13th, and we have a presentation about Antrea longevity testing, and this presentation will be given by Kumar. So I don't have a lot of context on this topic, so please, Kumar, go ahead with your presentation.
Sure, let me share my screen. Is my screen visible?
Yeah, it is.
So, hello everyone. So we did a small scale longevity test for Antrea on a Kubernetes cluster. So here I'll describe how I performed the test and what were the observations, that is the metrics, um, CPU usage, memory usage, and the bandwidth of Antrea pods. So we had a 7-node Kubernetes cluster. We had one control plane node with 4 CPU and 6 GB memory, 6 worker nodes with 4 CPU and 6 GB memory each. We deployed the latest Antrea, that is 2.1.0 of open source release in default in-cap mode, but we also enabled the node port local in the Antrea agent config map, which is false by default, but we enabled it because we have used node port local also. Then for monitoring, we use the Cube Prometheus. It is open source, and I found it easy because it has all the Prometheus stack, like Cube State Metrics. It has also Grafana with some pre-built Kubernetes dashboards, so I don't have to build anyone. Cube Prometheus was used as a monitoring solution. Now in a Kubernetes cluster, we had total 72 pods, including all, and we had 20 services, including one node port service and one node port local service, which we used for external traffic. And we had 14 network policies, including 6 cluster network policies and 8 Kubernetes network policies. And to generate some external traffic, load from external, we use the WRK tool, and we hit the endpoints of node port and node port local via an external machine, and we use WRK tool for that. So let me show you how the deployment was done. So in one namespace, we had 3 deployments, like you can see, tier 1 apps using Nginx image with 3 replicas, tier 2 apps, again 3 replicas with Nginx image, and tier 3 apps with 3 replicas using Nginx image. Now on all of these deployments, we had cluster network policies. As you can see, on tier 1 apps, we had a cluster network policy uh, to egress only to tier 2 apps, and there were no rules for ingress because tier 1 apps were exposed by a node port service. In one namespace, it is exposed by node port service. In other namespace, it is exposed by node port local. The rest all remains same in both the namespace. So uh, that cluster network policy was applied on tier 1. Similarly, a cluster network policy was applied on tier 2 to allow ingress only from tier 1 and egress to only tier 3. And that's why you can see red lines. Red lines are dropped traffic and green lines are the allowed traffic. And similarly on tier 3 apps also allow only from tier 2 and no egress. To generate some internal traffic, we use some client pods using Antrea toolbox image. As you can see, client 1 having 3 replicas, it continuously hit the cluster IP service of tier 1 apps. And client 2 pods, we had 3 replicas using Antrea toolbox image. It hit the endpoints cluster IP service of the tier 2 and tier 3 apps, and both will be dropped because of the cluster network policy. For external traffic, we had an external VM. On that, we run a script and we hit the node port endpoint of the tier 1 apps via we used some Kubernetes worker nodes. Not only one, we use multiple nodes to reach the node port endpoints of the tier 1 apps. And similarly, we did for the node port local also. In node port local, we used the nodes on which the pods were scheduled. So we use 2 different nodes for node port local and 2 different nodes for the node ports. and we opened the traffic from WR using WRK tool, 10 connections and 2 threads for each, uh, and via each node. Now we also had one egress, so that for that we deployed some um, 3 replicas using Antrea toolbox image, and it was continuously pinging some external IP, and egress was applied on it, and the node on which these pods were deployed and the egress node were different. We used a static egress in this case. Now let me show some observations which we got. So this is the observation for the Antrea controller CPU usage. During the first 6 hours, you can see there were no deployments, only Antrea was deployed and the monitoring solution was there. So during the first 6 hours, this was the till here. Uh, during the first 6 hours, this was the CPU usage of Antrea. Once we deployed the workloads and generated the external traffic, some cluster network policies got processed, but after that, the CPU usage came down and it was almost constant thereafter for the next 48 hours. And it is still running. It is still the same. And we did this multiple times, every time after deploying the workloads, after processing the cluster network policies, the CPU usage of controller goes down. The difference between the data points is 60 seconds between each data point, which is used to make this graph. Now,
Hi,
let me-
Kuma, why it takes 4 hours to drop for the CPU to usage to drop? That's during this 4 hours, is there any changes being repeatedly applying to the cluster? If you just apply their policies one time, I assume there should be only one peak of CPU usage. But
yes,
I don't know.
for the first 6 hours, deliberately I didn't apply any workloads to see the condition of Antrea controllers and agents in idle condition uh, without any workloads. Once I apply the workload, there is only one peak for cluster network policy, and then suddenly the traffic goes down. Uh, so that is what I meant. For the first 6 hours, there were no workloads. I had applied it.
You mean the CPU usage is higher
Yes, without
before
workloads.
you apply without work?
Yes,
That doesn't sound normal.
yes, it
But
was.
have you investigated why we have this observation? What CPU, what workload the CPU is being busy with?
I tried multiple times initially. I thought maybe some abnormality would be there, but and even for 20, I kept it for 24 hours also in idle condition. The CPU usage was around this only, and this is the CPU usage of Antrea controller pod. Now within Antrea controller pod, why it was uh, this case? I checked the logs, everything was normal. Uh, uh, so still I'm finding the reason for it.
Okay, I think this is a good finding, and perhaps this will reveal some problems in the implementation. That when it's actually idle, it consumes more CPUs. Maybe that's something we could improve. But we could take a look at this offline.
Sure. And this testbed is currently live, so I can share with you offline as well.
Sure, thank you.
Yeah. So, and after that, once the workload is applied, the network policies are processed. It's constant afterwards, almost constant. And now let's see the memory usage of Antrea controller. Again, this was the initial memory usage when workload was not uh, deployed for the first 6 hours. Once the workload was deployed, you can see here initially 45 46 maybe bytes, some 47, and afterwards here the workload was deployed and external traffic was generated. Then it shoots up, and but I don't see much difference. You see the y-axis, the units are just 0.5 megabytes, the difference in 1 unit. So it goes as high as 52, but I doubt that if we run the test for longer time, like I had run for 72 hours also, very uh, in very small terms, but it slightly goes, if you see, it slightly goes increasing in longer duration. Little it is increasing, but if we run for, I think for 4 or 5 days, then we see even if there is small increase, but it keeps on increasing a little bit. And so for this, we need to stretch the test for I think a 1 week or more. So we can get more clarity on this. So this was the memory usage of Antrea controller. Again, the difference between the data points is 60 seconds here also. Now this is the bandwidth of transmit and receive bandwidth of Antrea uh, controller. Initially, during the first 6 hours, it was idle, so it's negligible. Then it shoots up because when I initiated it, I had a huge external traffic, so I scaled it down because I had less powerful machines, only 4 CPUs, so node usage of the CPU usage of the nodes were too high. That's why I scaled it down. And afterwards, it's 20. You can see 28 MB per second and constant almost for the next 48 hours or so. And similarly, you can see the receive bandwidth, almost similar graph, but there is a difference between in y-axis. Here you see it's 45 MB per second receive bandwidth, but here you see it's 26, 28. So there is a significant difference in the transmit and receive bandwidth. Although the graph is same, graph pattern is almost similar, but the units in the y-axis are different here. This is the observation from the Antrea controller. Now let's see Antrea agent. We have total 7 Antrea agents. So CPU usage is, the pattern is almost similar as Antrea controller. In the first 6 hours when it was idle state, it was little high. After deploying the workloads and the generating external traffic, it went little down, as you can see the inflection point here. So it's almost similar to controller's pattern. And again, I checked the logs and all, and it was same. And I performed this test multiple times. The pattern was same. So in idle state, one observation is that in idle state, the agent and the controller, both CPU usage is little high. And after that, it is constant for the next 48 hours or so. Now, Antrea agent's memory usage, it is for the first 6 hours, it was less. After deploying the workloads and generating the external traffic, it went little high. But here also, uh, as I said in the controllers graph, if we stretch the test for longer duration, I suspect it goes little high in longer terms, because I had a graph of 72 hours also previously, which I did, and that I didn't share because in that uh, Antrea controller got rescheduled on another node because of the node CPU usage went high. So that's why that graph I have not shown here.
Does each color represent one Antrea agent instance?
Yes, there are a total 7.
Okay. I see.
So some are different because of the workloads. On some nodes there are more workloads, on some nodes there are less. So that's why it's not same all. Some graph is some have less, some have more. But as you see on the y-axis, the difference is not much. 2-3 megabytes. If you see the higher one, it's as high as 115 megabytes, and if you see the lower is 105. So we can say the range is between the max and min range difference is 10 megabytes only.
Did you have some metrics for other Kubernetes components like Kube Control Manager and Kube Proxy? I suspect the Golang based applications may have the same pattern for the memory usage. But
Yeah, I
if you
have.
have this,
Yes,
yeah,
in the dashboard, I have a lot of observations, but I didn't explore that. I'll check it and I can share with you also as well. I can share the link. It is live, so we can take a look at that as well.
sure.
And this is the bandwidth of Antrea agent, transmit and receive bandwidth. So it's as expected. If you see here, it's when no workloads were there, it was very less. It was almost zero idle. And when it started, it shoots up very high because, as I said initially, I had a huge external traffic. I scaled it
Uh,
down.
so I have a question here. What does it mean by transit bandwidth of Antrea controller or Antrea agent? Is this traffic is belongs to Antrea agent? How do you capture the metrics?
Yes, these are captured by the kubelets. As I said, I used Kube Prometheus, and I found it easy. I didn't have to do much there because it has kube state metrics, kubelet, node exporter, all tools it has inbuilt. So it gives us the you can see in the top. We here we select the which from which pod we want the bandwidth, and on
But I suspect that this is not really traffic specific to the process, but the traffic generated by the whole network system.
yeah, because it
So
host network
because
means.
like so maybe this will not if this belongs to the host network, this metrics for Entry controller and Entry agent maybe not may not make a lot of sense because they are not really related to the component itself,
Uh,
unless this is the traffic generated by the process or received by the process.
um, I doubt this thing because we also have. I'll share the dashboard with you. We also have the traffic from each interface. In that, if you see nodes, uh, the node's primary transport interface traffic, it's more than 100 MB per second. So if that was the case here also, we should have it. If that it should have more than 100 MB per second. So we had from each interface, whatever interface in the host on the nodes network namespace, that is host namespace. Also the bandwidth on each through each interface. What is the receive and transmit bandwidth? That data we also have. So that is not same as this one. It is that is bigger than this.
Okay, maybe then you could also compare, for example, Q-Plotly and Entry agent on the same node and to see if they have the exactly same transmit bandwidth. If they are same, I believe this belongs to the whole network namespace instead of each component. And I don't really know if there is a tool to collect process level bandwidth. So yeah. Besides, I don't think Entry agent and Entry controller can generate so much traffic because there should be only management communication. If the cluster is static, there should be basically there should be very few traffic generated between them. Yeah, but we could check this offline.
Sure. And again, there is a difference between transmit and receive bandwidth. In here you can see the y-axis. Here 30 MB per second. Here it goes as high as 45 MB per second. But the pattern remains almost same. So that's all. I know the scale was less. We had less. This I estimated. My estimate was not correct regarding the node CPU. That's why initially I kept low. But when I ran the test, initially whatever workloads and traffic you are seeing, uh, I had double workloads. I had double traffic, but node CPU usage exceeded 100%. Nodes left the cluster and rejoined, and Antrea controller also got rescheduled. That also happened when I ran this test. So second time I scaled down everything. But if you have any feedbacks and questions in future, next time when we perform the test, we could incorporate those, and we'll have a powerful machine next time so that it is more than double or triple of these workloads and traffic. Thank you.
Thank you, Kumar. I have one comment. It's about the collected metrics. I feel in addition to the kind of one you have done, I think we should have some metrics or do a collection of abnormal events. For example, the reschedule of entry controller you mentioned, and also the restart of any components so that we can identify potential issues. Remember, we had one issue. I'm sure knows more details. Is that there is one component, one container will be restarted every day at a specific time. And if we have this kind of test, I think we should be able to catch that kind of events and fix it before releasing it. Yeah.
Yeah, for the first time in which said the controller got rescheduled on another node, I have the support bundle. I have the logs of it, and I checked it. It was due. As I said, the nodes left the cluster and rejoined. Um, so that was the cause of it. But I have the logs. I have this support bundle of it on the same test, but I have saved it. I can share with you.
Yeah, I mean, the collection of the abnormal events, like
Mm.
reschedule and recreate of any container or any port, or maybe even the uh, generation of any error logs or warning events might may be good to be collected, so we can investigate what might be wrong when the components runs a long time.
Okay, understood. You mean the alerts, the kind of thing we could have so that uh, we have the events.
Yeah, yeah.
Yeah. Yes, we can do that, I think, because Kube Prometheus provides alert manager also. So that can be done, I think. Thanks.
By the way, can you switch to the second page of your slide when you talk about the application? Like this one. What does this lines means? The red and the green line.
Yeah, the red lines mean the traffics which are dropped. Like for
Oh, I see.
yeah, for client 2 pods, it will continuously hit the traffic, hit the cluster IP endpoint of tier 2 apps, and cluster IP of tier 3 apps, but both will be dropped on the tier 2 side and tier 3 side because of the cluster network policy applied, which allows for tier 2 it is that allow ingress only from tier 1 apps and allow egress only to tier 3 apps. Similarly for tier 3 we have allow ingress only from tier 2 and allow and don't allow egress anywhere. I just for the sake of replication, I just use this as a 3-tier application design. That's why.
Okay, so actually there are 5 deployments in this cluster.
In this one namespace. In another namespace, I have node port local and rest all same. So it is 10. And
I
then
see.
also we have one egress namespace for this one. So it's 11.
Sorry, one namespace is for testing connectivity and in-class connectivity and the net policy, and another namespace is for testing egress traffic. Do you mean that?
One for node port, one for node port local, and one for egress 3.
Node port. Okay.
Yeah, like this one is one namespace. Namespace 2, same as this, just instead of exposing tier 1 apps via node port, I exposed it via node port local. That's the difference in the second namespace. Rest all remains same.
Okay, maybe I need to understand the why we have this structure. What's the reasoning behind each application offline? Yeah, but yeah, it's a minor thing we could discuss offline. I just want to keep the topology as a list for a single namespace. The topology could be simpler to understand, and it might be easier to troubleshoot or to predict what's the expected behavior.
Yes, that can be done. I initially, like, I had written, I was hitting the endpoint via an external machine. So for node port service, I had used 2 Kubernetes nodes for node port local. For node port local, the node IP should be fixed when I hit from external machine. So that's why for node port local, I had reserved another 2 work nodes. So that's why for I felt it is more easy for me. That's why I segregated it into namespaces. But yeah, from your point of view, I understand. For investigating point of view, it would be easier if it is single namespace.
Okay. I don't have other questions. Thanks for your demo and answering my questions.
Thanks, Sean. And do we have any other question for Kumar? Waiting a few more seconds.
I think we will extend this test for currently it is for 72 hours, right? So we wanted to extend it for maybe 7 days. Then I think we'll get more data. And also, like, the 3-tier architecture is there. Like, we wanted to replicate exactly like how it is deployed. Like normally, the DB is in the backend and then proxy and then client. So that kind of architecture. So if any other suggestions also in other deployment scenarios, we can do application deployment and have some extended metrics collected.
Okay, and I have 2 questions actually. So one is more about test designs and the goals of the test. So is this about testing the behavior of an Antrea cluster with respect to long-running applications, or about also testing the behavior of long-lived Antrea clusters? So meaning, you know, are we focusing more on the application behavior in Antrea or on the behavior? I think we are, I mean, or on the behavior of the Antrea components themselves. I think it might be more the latter, right?
Yeah, I mean, basically we want to check the Antrea metrics,
Mhm.
not the application specific, but obviously like application behavior also needs to be seen, like with when application is deployed, how Antrea is behaving. So
That's correct.
Yeah.
So my comment here then on test design perspective is that it seems to me that after the initial configuration, the control plane is pretty much static. So we don't change any configuration in the Kubernetes control plane. Is that right?
Yeah, I think, yeah, I mean, once network policy is applied, I don't think there will be any change in control plane as such.
So let's say that from the Antrea perspective, therefore, we are covering the data path components, mostly open with switch, but we don't get any, we don't get a lot of feedback about the longevity behavior of the remaining control plane components. Therefore, maybe something else that might be considered for this scenario is adding a bit of churn on the control plane, constant churn, like, you know, continuously deploying and destroying applications, adding and deleting network policies, which is, you know, also typical, if you want, of a skill test execution plan, which applies also to longevity testing. I don't know if you have already considered this and what will be your opinion on it.
Yeah, I think that is a good suggestion, Sabaru. I think we can do that. But the thing is, I think we also want to include that, and as well as the other components of the control plane, like that also is, I mean, that is also component which impacts the overall performance, right?
You mean
Yeah.
other Antrea components or the Kubernetes components?
Kubernetes components.
Okay, got it.
Yeah. Because I mean, the Antrea is heavily dependent on those Kubernetes component as well, right?
Yeah, and those components depend on Antrea. It goes both ways.
Yeah, yeah.
And then the second question that I had is about what is your plan for executing this test? So are we going to, for instance, to run a session of longevity testing before each upstream release? Are we going to keep a test bed continuously running, or do we have any other plan?
Yes, I mean, we wanted to keep it for a longer time. So so again, like these test beds are like kind of a development test bed, which kind of leased for some period of time. So we have to think about that. Like maybe we can check with QE and sync with them, and then plan like we can run it like every. So we have plan for this. Like we want to run it before every release. So
Okay,
yeah, that is in the plan.
thanks. Thanks for your answers, and I don't have any other question. So I don't know if in the meanwhile anybody has any other question. Maybe I give other people ideas for other questions. All right, let's wait 10 more seconds. And the time's up. So thanks a lot, Kumar, for your presentation. We are looking forward to see these longevity testing being part of the, let's say, the portfolio of quality tools that we have for Antrea. So thanks a lot for sharing this data. Thanks a lot for setting up this analysis. And I would like also to thank everybody else for attending this meeting. And we'll meet again in 2 weeks' time. Thanks a lot for attending and have a good one.
Thanks a lot.
Thank
Thanks,
you.
everyone. Bye.
Thank you. Bye-bye.